Greetings. Thanks for listening our presentation. I'm Tony.
I'm Marcus.
Our group is doing an e-health app for dietitians. In their daily work, they have to deal with large amounts of data of food and nutrition products, which are all listed on papers, and it is very inconvenient to them to bring so many papers to work. So we are going to develop an app for them to store data, review data, and do some calculations and comparison. We cooperate with another groups to do the same app, and our group focus on two things: to make a unified standard schema of the nutrition labels, and as well as investigate an image recognition input. So why we have to develop our standard schema? Because in Hong Kong, um, the nutrition products do not have a standard for their nutrition labels. So their labels will maybe appear different kind of nutrients, and the nutrients names are maybe different, and also their formats may be different. So we looked up the standard of other countries, for example, the US and China, and also we have consulted opinions of an local dietitians. So we comes up our own schema of the nutrition labels. And for the image recognition input, um, it is to take a photo of the nutrition label, and we have a function. We use the T-Server OCR library to recognize the image and turn it into a text, and then we have our own programs to extract this recognize the text and then automatically fill in the forms, so that the users do not have to type all the all the values by manual, and it will be more convenient to them.
Specifically, we need to apply string processing on the raw image recognition output. We offset the pattern in the output data and create a function which can automatically correct the errors and obtain the value of nutrition contents. For instance, our function can recognize the nutrition contents and its corresponding units. Since the value of nutrition contents usually placed behind them, so we obtain that piece of data and we make use of that piece of data by some libraries, and we process it and we can obtain the original values. Actually, we have done 3 experiment results. Our experiment results are based on numerous times repeating, because the performance highly depends on the resolutions of the input, so that we need to take numerous photos to count the performance. There are 3. The first experience is that we take the nutrition label behind the product as input, and the second experience is that we take nutrition specification sheet with bordered table. And the third one is similar to the second one, which is the table without border. As shown on the upper results is that since the performance are highly based on the resolution, so that the nutrition label performs best. Since the nutrition label is small, so that when we take a photo, the resolution must be the highest. And the second one is the unbordered table. Since the border of the table usually becomes an interference which affects the performance.
We may also investigate some way to do some image processing or the recognizing image. For example, the image may be not flat, maybe it is some kind of bent image. We may scale the image so that the image is more easily to be recognized by our T-Silhouette OCR program. And we may also use some methodology to erase the borders. And in addition, we will training data to our T-Silhouette library, and it will enhance the accuracy of the image recognition function. And that's the end of our presentation. Thank you for listening.
Thank you for listening.